Good. Okay, so just to sum things up, differential equations on the screen. Also, this is not really the time for first period. This is later than first period would be. We'll figure out which lights we need to turn off and stuff. But okay, so differential equations. So one thing that is interesting about differential equations is that you have x's and y's in the equation. Right? And then what else do you have in the equation that's kind of interesting about differential equations? Yeah, and the derivative. And they have what they call like higher order differential equations where they could have like the second derivative within and the third derivative within the equation. And we will look at that a little bit today, and then after that we won't really look at that anymore, and we'll focus on differential equations that only have the first derivative in there, because anything higher than that is a little bit outside the scope of this class. So we have looked at differential equations a lot. We've just looked at differential equations where the first derivative is isolated. So anytime we said f prime equals something, that's technically a differential equation. Derivative, you've solved for it. Anytime we said dy dx equals, anytime we said y prime equals, that's technically a differential equation. It's just a differential equation where you've solved for the derivative, and so that's we're going to look at differential equations where the derivative might be somewhere within the equation, and we talk about solving for the differential equation. Does that make sense? Okay, so we're getting a little bit deeper into studying differential equations and looking. Differential equation is a function, not a point. Equals a point, you get y prime equals a function. Does that make sense? Okay. All right, so example 5 is going to say verify that y equals c is a solution to y double prime plus y equals 0. So this notation just means the second derivative plus the function equals 0. The second derivative plus the function completely cancel each other out and you get nothing. Okay, so we're going to go ahead and take the original function y equals c sub 1 cos x plus c sub 2 sine x. That's the original function. And then go ahead and tell me what's the c sub 1 and the c sub 2? What are those within this problem? They're constants and they're coefficients, right? So they're just numbers that happen to be in the front. They're just not telling us what those numbers are. Okay, so if we take the derivative of c sub 1 cos, what do we get? Okay. And if we take the derivative of c sub 2 sine x, what do we get? Positive derivative. So the derivative of okay, and then the derivative of positive 2 cos x. Okay. And so now what we're going to do is we're going to say, okay, y double prime plus y prime equals 0. If we write it out with that notation, we're going to say y double prime is negative c sub 1 cos x minus c sub 2 sine x plus the function c sub 1 cos x plus c sub 2 sine x. So this is y double prime plus y equals 0. And is that true? Yeah, so this one cancels with this one, and this one cancels with this one, and that is true. So we proved it. All right, how do your brains feel? Brains are good? Okay. All right, next we're going to look at kind of a vocabulary term, which is not going to make a lot of sense today. So we'll look at it today, and then we're going to come back to it later. We're actually going to graph differential equations, which is going to give us something called a slope field. And so we're going to look at this vocabulary term. It's going to show up a little bit today, but it's going to show up a little bit later as well, okay? So this is going to be something that kind of might not make a lot of sense today. But by the time we get finished with the unit, you'll be able to see more about what it means. So the phrase is equilibrium solution. You might have heard it maybe in the context of a science class or something. You'll hear it in terms of populations, the equilibrium solution, yeah. So equilibrium solution is where there is, my lid. Okay. The equilibrium solution is where there is no change to the function. It is where the derivative equals 0. And where does the derivative equal 0?
You guys just have the horizontal.
Yeah, where there's a horizontal tangent line. Yeah, okay. So we're gonna say the derivative equals 0, so that's a horizontal tangent line. Okay. Which is also going to be if there's a horizontal asymptote. So Derivative equals 0, this would be talking about how to find the equilibrium solutions if you're doing it algebraically, because derivative equaling 0, that's algebraic. Horizontal asymptotes would be a little bit more, or looking at the horizontal tangent line, that would be if you're doing a little bit more geometrically, like if you're looking at the graph. So that's not as much what we're going to do today. So for example 6, though, if it says find the equilibrium solutions and you're doing it algebraically, then you're going to be looking for where that 0. So find the equilibrium solutions. So this is going to be kind of like back in the first semester where we said a lot of calculus was learning what words mean and what they're actually trying to get you to do. So here, anytime you see equilibrium solutions, you're just going to say, oh, make the derivative equal 0. That's all I have to do, is make the derivative equal 0. So here, the derivative is the dy dx. The y just stands for y. If we were to able to isolate y, that would just represent, oh, that's the original function. Y is just the original function, okay? So here they're saying it could represent original function. Maybe they have a list of original functions they'd give you, so maybe y equals e to the x, maybe y equals sine x, maybe y equals cos x, maybe y equals a polynomial function, anything else. They're just saying that the derivative is y squared minus y. That's all they're saying, okay? So what we're going to do is we're going to say, okay, the derivative equals this, so let's go ahead and take the derivative, set it equal to 0. Because we want the equilibrium solutions, and then we're going to solve it. So if you take this away, if you had y squared minus y equals 0 and you wanted to solve that quadratic, because that's what it is, it's a quadratic, how would you solve that? Take out a y, you're going to factor it, right? And it's a GCF factoring problem. So we're going to take out a y, GCF of y, and then when you take out a y, what's left over? Y minus 1. And this problem would have two solutions. What are the two solutions? Y equals 0, y equals 1. And so here, instead of saying, oh, these are the two solutions for y, we would just say, oh, these are the two equilibrium solutions for the differential equation. The two equilibrium solutions would just be where the function equals 0, where the function equals 1. All right. How do your brains feel? Brains are okay? All right. I'm going to give you guys a copy of the assignment. Okay, so this assignment does not have enough room to write. You are probably going to have to write on a separate sheet of paper, unless you write very, very small. Okay, so this worksheet is a little bit of trial and error. That's not how this whole unit is, that's just how this worksheet is. This worksheet is the only worksheet we have this unit, I'm pretty sure, don't quote me on this, but I'm pretty sure, that has differential equations with second and third derivatives on them. This might just have second derivatives. I think there's only second. Yeah, looks like there's only second derivatives. I'm pretty sure this worksheet is the only one that has second derivatives on it, okay? So this is just an introduction to the unit. Do you kind of understand what differential equations are? And then after this, that's when we really start to kind of dive in. So don't feel like the whole unit is going to be like, oh my gosh, it's like a guess and check unit. It's not, but this assignment kind of is, okay? So the first differential equation says the derivative minus times x times the function completely cancels out and equals 0. That's what the first one says, okay? So these are all of our different options here. This is the function, right? So they're saying the first derivative minus 2 times x times the function equals 0. So you can see here we have e to the negative 2x, and we know the way derivatives work, right? So e to the x, the derivative of e to the x is itself, except we have a chain rule going on. So we would take the e to the x and we would multiply it by negative 2. Does that make sense? Okay, so if we think about a problem like number 1, there's going to be a little bit of strategy for doing this worksheet. So for number 1, I'm just going to write y equals e to the negative 2x, y prime equals e to the negative 2x times negative 2. Now, is number 1, maybe I'll just go ahead and write this, negative 2 e to the negative 2x. Is number 1 going to go with A? Yeah, it's kind of similar though, but there's an x in the second part of the problem. You guys see that? That's too much. It'd be this minus this, but an extra x in there, it's not quite working. What about B? Let's look for B. It works. So if we did y prime plus 2 times y equals 0, is that true? So this is y prime plus 2y equals 0. Check. So 1 is B. That makes sense? Okay. All right, so 2. So I got y equals e x to the third. Y prime, what's y prime? Okay. So would number 2 go with A? Could number 2 go with A? Could it be y prime minus 2xy? No. We see why number 2 couldn't go with A. Yeah, that doesn't quite make sense. Okay. All right, number 2 is we might have to do a double prime just to see. Looks like that was our last y prime only answer, maybe. So there's a little bit of strategy involved here. You can kind of see, when you look at it, you can kind of see which answers, like this one, you've got a 3 involved. So when you look at number 1, you go, well, number 1's got a 2 in it, so it can't possibly be number 1. So you'll start, as you're finding your derivatives, you'll kind of get an idea for which problems kind of make sense for that one. When you find your second derivative, what's going to happen when you do your second derivative of this one? It's a chain rule, but what else is it for your second derivative? It's a product rule. So what's going to happen when you do your second derivative is you're going to have a plus in there. It's going to split it and make it more complicated. And so that's going to end up with something that has multiple pieces. Do you guys see? And